So yeah, currently we're playing around with um, some player controller related stuff. Uh, Last episode we did the updating of the camera position and the player transform, and we got to a point where we can move our character around, swap on an AFPS camera, and we can of course swap to another camera, and as you can see our player is able to move around. I do not disable movement even though I swap camera. Yeah, so that's let's see if I, well, that doesn't, oh, well, I have to right click of course. Yeah. But right now, as you can see, our player is able to step through walls. It does have a bounding volume, but no collisions are checked. We will do a somewhat janky implementation. Needs to be safe in the future, since we can resize vectors and lose the pointers. But we could do some collision checking before we do gravity, because if we implement gravity and jumping, we'd end up with a player character that just goes through the floor every time, and we're not interested in that. We did this, so let's move that. Let's see, helper flex, maybe temporary. This is some information in the controller. Let's see. We would like to be able to get a reference to a bounding box static colliders, which we will store. And this is what I mean by janky. This is not how you want to do things in the long term. I plan on doing a physics interface, which will be a singleton, and therefore therefore yeah. Um, Let me get regain my thoughts. And from that we could get whatever bounding volume information we wanted from anywhere in the application, and thereby we didn't need to link these by some potentially dangling pointers. Yeah, it's not a great practice, but it will work at least for now. Um, and we will, when we create the character controller up here, we will pass in a reference to static bounding boxes. Is that the right one? Yeah, I removed the old one. Yeah, but I really want to emphasize this is not a reliable way to do it in a larger and more complex system. It is like the null pointer or raw pointer stuff here in terms of the camera, just some temporary stuff that we would like to do to be able to uh, handle some collisions. Check collisions. And let's implement that in our update method here. We will update that eventually. And we will do some, borrow some, step out of the player, then out of the game objects, then into the physics, and then do some collision checking. And we haven't actually implemented a way to check bounding spheres. Let's see. Instead of object, let's do player sphere. Static collisions. Static objects, a bounding sphere instead. Layer sphere. And yeah, we want to compile a list of different spheres. So we simply ask the query system squared distance to point on ABB, and we check our static objects, and we of course ask for the player sphere center, float distance squared, and then we have a float radius squared. And if that distance, if the distance squared is less than the radius squared, we will prompt by telling the system, am I allowed to do that? PCH, yeah, I think I'm allowed to do that inside the CPP file. Collision between player and static object index I. Let's do that. And right now we won't be passing out the collisions. Physics. Player, check collision. Player sphere, check static collisions. Yeah, I'll definitely need to. Then can I pass in a null pointer here? No. Okay, for now. I'm gonna remove the part. I'm gonna make a comment here and then I'll just remove this part for now. Let's see. Since we will probably do that eventually. Whoops, I don't think I got done, did I? Yeah, alright. As you can see, no, you can't see it, but index 2, 3, 4. So we actually do have collision detection working, which is great. And we can even check it with the arbitrary camera, or rather, oh well, the physics system doesn't like whenever the time step gets too big. It can't check if they're going to collide, since it's not continuous collision checking. It's just time step based, or whatever you call it. So let's see here. And we are actually colliding. Great stuff. Great stuff, great stuff. Okay. Let's swap back to the old method. And let's do this and place back the ID, then continue. I was going to do that anyway. Let's see, and we would need to update the method to the old one as well. Delete the void here, delete the thing there. And then of course we would like a vector of unsigned ints collisions, which we will store the values in. Let's just do the, let's see. Yeah, I want to do the debugging out static colliders. Yeah. Let's do that. Anyway, camera controller is not needed right now. We do not need the PCH, we do not need the swap chain, the global settings. Camera is not needed for now. The renderer, math, main, CPP. Yep. Maybe we want to store the we have different methods to recalculate some stuff. Yeah, we could actually just pass out the information. Huh. I think that we're doing this twice, potentially, if, I mean, calculate penetration depth. Since it's a sphere, we're already doing it. But for ABB and ABB collision, it's somewhat different. Yeah, maybe contact normal. Maybe we want something like a contact normal to be passed out. Maybe we don't want the indices of the yeah, maybe we just want to get the contact normal and calculate the yeah, maybe we just want to do it all in one sitting. So we could get the contact normal and penetration depth from this. Yeah, we could do that instead. So we would like a G vector out contact normals and C vector of floats out penetration depth. Hello, how are you doing? I'm pretty good. I'm pretty good. Things are going fine with the engine and so forth. So, how did the 100th anniversary of Turkey go? Let's see. Yeah? Do you have any new updates on the software? So you're playing around with exceptions. Uh, is it fun? No, that's how I remember exceptions. Yeah. Let's see. Yeah, I feel you, man. Let's see. Let's move this around and let's test here. So it collides a bit with the ground. Um, well, I don't know. Um, it seems like you're better at naming stuff than I am. D plus plus, D D sharp. I think D sharp is better. All right. Error plus plus. Yeah, that's a good one as well. Let's see. Uh, and then we take the radius and squared and take the square root and store the penetration depth. Let's see. I have an error somewhere. Yeah, I need another bracket, even though it's not needed because we do not need to do that. So I store the penetration depth, which is whenever we have a distance squared that is lower than the radius squared, we know that the penetration depth um, is equal to the radius minus whatever distance to the object we have. Um, then we can calculate the contact normal um, as we did in the resolution here by subtracting the center of our object which we are comparing to, and then getting the closest point from there. We skip it if there's no collision, and there can't be any collision. We don't want to spend time calculating contact normals for that. Let's see. So we want something normalized here, vector normalize, and we want to subtract the player center and the query of the get closest point on ABB, and we pass in the center again, since we want to find the closest point compared to the sphere, and we just pass that in, and of course remove the semicolon, and we should now have contact normals for our and penetration for our collisions. We could just do some dumping of the information here afterwards. Contact normal, and we will take the normal here and parse it out, or rather not parse it, print it out. And since it will hold 4 components, but the last one will be empty, we will just print it for good measure, and then we want the same for the depths inside the penetration depth. And we want to just print that out. And of course we do not want an S on that, even though it's just debugging. Elevate script, yeah. Yeah, that might work. Let's see. So the let's swap out of the player camera here. So it says that there's a collision between the floor, which is index 1, which has a contact normal of 0 on the x, a plus on the y, and a 0 on the z, meaning that for this collision, do you think easy script is taken? And if we move the player character here into the wall, you will see that the contact easy script. You think that is taken? Okay, let me see. 2 seconds. Well, whoops, I'm messing around here. All right, let's see. Let's then swap to the free floating camera here. So yeah, our contact normal gets correctly calculated. Right now we have two collisions, one with the floor, one with the wall here, and the positive x-axis is here. Actually, I need to enable the coordinates in our renderer. Okay. Well, I'm not good at naming stuff. Let's see. I wouldn't mind drawing our coordinate system, at least for debugging. So as you can see, our y is going up, the x is going that way, and the c is going that way. So when we get a contact normal that is pointing in the positive x direction, you can see here, it means that it actually wants to push the object out this way. The floor wants to push the object upwards. We do have a penetration depth. Bacillus? What does that mean? So yeah, you can see we have a penetration depth of something close to a lot. I would prefer that it actually didn't collide with the floor. Well, okay. That might not be a too bad of a name. I don't know. Uh, yeah, yeah, that's not too bad. At first I was like, what on earth does that mean? But the more I think about it, yeah, I think I like it. But do not take my advice in terms of that because I'm not great at naming stuff. For some reason, or if it's equal to, yeah, that is the problem. So right now we won't have collisions with the floor. Blitz script, yeah, you could do that as well. Maybe call it fire script since it's burning blazingly fast. Yeah. Okay. And as you can see in the opposite side of the whole scene, we get another, or rather a different contact normal. All right. We have our JavaScript. To me, that sounds a bit funny. All right. You feel the same way. JavaScript. I'm doing object-oriented programming in JavaScript. Let's see. So we have our collisions here, and then we want to resolve them. Usually, we do collision resolution, physics-based. Maybe we want to split this actually. Maybe we want to split this into player related stuff because it's not really related to the physics engine. Player collisions. These are old functions, I think. Yeah, let's move it actually. Let's have the query at the bottom. Exequi. Yeah, that might work. Player collisions. Yeah, that's better. Maybe just move it down here. Nah, it's fine. Yeah, I want to untangle the physics stuff and the the player related stuff. Let's just add here needs a clean up after the physics interface has been made. Yeah, we definitely want to do that. Needs a cleanup when physics is interface is done. And let's just do some collision resolution here. The same way, namespace, player. Let's see, how did I name it? Player collisions. Void resolve. Collision. Position. Collision position. Collision position. The renderer, I'll not need that. Let's see. Let's create a method here. Okay. Let's do namespace and move that into here. I can't spell. Also, we do not need the GXE here. And resolve the collision position. Positions. And we want to pass in just these two. They will be mirrored. And we will do some more stuff. Just messing around with some stream stuff. There we go. Um, so yeah, we want to resolve these collisions. Perhaps we want a reference to the transform. Yeah, let's do that. We pass in the object transform reference player transform. And then in our player controller, we want to recalculate the transform as the last thing we do, since it just grabs the position. So let's do int collision when c is lower than the contact normal size. C++. Wow, C++. What a coincidence. I'm using C++. Yeah, we do not have any methods for handling that, but yeah, the basic idea is that the player transform that position gets updated by, let's see, the g vector, or rather, let's do a g float 3 new added position equal to math library, not load float, store float. Okay, let's see. Let's initialize this as 0. And then store the result of our computations here. Math, scalar, vector multiply scalar, the contact normals of the current collision by the penetration of the current collision. Yeah. So we want to add that position. And then let's see, does this actually work? Or do I have to implement it? No, it doesn't work. So inside gfloat, we could do an operator. Let's see the gfloat 3 operator plus and we do a gfloat reference to the other one. Let's do it inline here. 3 other one. No, it's not undefined, dude. My dude, return a gfloat 3 with this dot x plus other dot x, this y plus other dot y, this c plus other c. Let's see. There we go. So this should allow us to at least not in here. Well, we still can't do like that, but we can do like this. So yeah, we simply update the position. Okay. Yeah, we do have some problems. Let's see. Let's copy that. And then inside our inline library here, let's do some operators. Where do we have our operators? We have our operators down here. Inline. There we go. Does this compile? No, we still are in trouble in terms of let's see, how do I get the other things to compile? For some reason. Let's do std call. It really doesn't want to. Do it like that. If it's not inline, it won't be bothering me. Or well, it will. Man, it sucks. Okay. I'm gonna let's see. And that would compile or what? No. I've been messing around with this before, and I really do not like it. Okay, I'm just gonna be verbose here. And then I'll fiddle around with that some other day. Uh, let's do something like this. There we go. Y, Y, C, C. Yeah. Let's see. Let's what? Oh, wait a minute, wait a minute, wait a minute, wait a minute. Maybe it did work, maybe I'm just... And then inside the play, maybe... No, that's not it, is it? Player collisions, player controller objects. Let's see. Let's see. Whoops. So it's telling me, oh, whoops. Definitely window. Yeah. Okay. Mm, mm, view window. I mean, god damn it. Just what I needed. Oh well, it does. What is wrong? A lot of different warnings here. Warning. Suddenly the linker doesn't. If I disable this, everything will be fine. I mean, and inside the... Did I do a redefinition? It does know where to load it from. Maybe Oh yeah, I think this is not linked properly. Is it? Oh well, it is. I think the query is outside the... Huh. Great to hear, man. I ended up struggling with the thing here. For some reason, the linker doesn't accept what I did. Let's see if I just do blank out this, or rather blank out all of this. Do I still get a linker error? That I do, because it was supposed to go there. Collision checking. The namespace query is actually inside the physics. Yeah, I think we want to move that. Now we might end up in a whole other situation. No, I don't think that would be legal. That would definitely not be legal. Let's do the query first, since every part of the system is going to use it. Let's see. Our resolution in here. Query, query. Layer collisions. This is somewhat annoying. Inside the collision resolution. Let's see. Collision checking. We have the query stuff here. We have the physics stuff here. Maybe we need to define it before. Everything else here, let's see. Oh my god. Um, Maybe, let's see, checking game object data. We do have that. Oh my god. Everything is falling apart. Oh, now I see. It's inside the physics namespace. Thank you, IntelliSense. Let's see. Physics. All right, we're down to one error, or rather, yeah, can't find these functions here inside the collision resolution thingy up here. The namespace gxe query, which I do think is supposed to be declared here. Well, the definitions aren't to be found anywhere because they're inside the physics namespace. Well, that was the error. All right, finally, that was a stupid mistake. So now we have, where did we get to? Yeah, we do not have any real collision resolution. Let's see, because I have not activated it yet, I have only built it. And then I got stuck in refactoring land. At least IntelliSense helped me out. Then I want to, yeah, we need the collision resolution function here, or rather header, physics collision resolution header, and then we want the resolve player collision position. There's something with the naming there that's not great. Player collision positions. There we go. And we will, of course, use that. Then we will pass in our transform, our contact normals, and our penetration depths. And we will see if we have collision resolution. By doing that, I will move out to the free floating camera. Well, we do not have any collision resolution here. I'm interested in, does this even fire? Let's test this. Try to resolve collision by moving to and let's see what our information is. So let's swap to the camera again. And let's just, so it doesn't really resolve anything. It doesn't try to resolve anything. Let's see. Why doesn't it do that for some reason? Did I? So in the checking algorithm. Oh, I disabled the while I was doing the debugging because I didn't understand what the compiler was telling me. Embarrassingly enough. All right, of course there's no collision when there's no collision checking. Oh, there we go. Oh, it just keeps adding. Well, it is something, but it's definitely not. Uh, let's see. Yeah, so it keeps on adding it. Well, inside the player controller. And let's do C just to check if we go out of bounds. No pun intended. Um, huh. Let's see. So the transform gets updated, but the oh yeah, I know why. Because the bounding sphere isn't updated. That is why. This goes with this bounding sphere. So that's a missing step. Recalculate bounding volume. We simply create that. And we update it like this. We could actually just skip this then and call it every frame. Let's do it before. No, let's do it after because we use the transform. Then we update the bounding volume. There we go. Now we can't go through the walls. As you can see, it corrects my position. We have de facto created collision detection, but only with the static objects. We could do the dynamic objects as well. Yeah, simply by adding another step here. Maybe we want, and as I've mentioned, you shouldn't do this at home. It's really not a long-term solution. dynamic colliders. We just want to show how, or rather, I just want to show how easily these things are updated. Dynamic colliders, and then inside our application here, we will pass in a reference to a dynamic bounding boxes vector. And then inside our player controller, we can also do checking for, we can actually use the same method. I can't spell, but we don't care. And now I think we should have dynamic, yeah, now I can't move through this object. Great stuff. So if I swap to the free floating camera, we can now see that our player character can't move through walls. It can't move through dynamic objects according to its sphere. As remember, the blue box here is a sphere. So as you can see here, it actually is able to penetrate a bit of the box because the box is not correctly representing the sphere. I think I will do another debug visual for that. But anyway, we do have collision checking for our player, which I think is pretty awesome. So now we have, let's see, no, let's just restart the application. So now we have a player camera where we can move around. We can't go outside the scenery. We can't go through objects. Yeah. So the last thing that this player controller needs, which we on purpose didn't do before the collision stuff, is some sort of physics simulation of sorts, which will allow us to jump. And we will borrow from our physics system by giving the object here a downward going gravity pull and a possibility of having a movement vector. Yeah. So basically you add the upwards going vector and when you jump, and then to the current forward going direction, and then gravity for each frame, or rather time step, gets applied to the object, pulling it down and thereby giving the jumping trajectory. And since we have collision checking, we can make sure that we do not fall through the floor. Yeah. So if you're following along on the YouTube series. Yeah, it's pretty awesome. Thank you for tuning in on YouTube. I will segment this a bit part of the video series on YouTube. I'm sorry if I'm finished. Uh, um, what do you mean? No, 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 no. I'm not going off stream. I'm streaming both on YouTube and Twitch. And on YouTube, I prefer to disable the stream every time I think I completed a topic. So that if anyone uh, wants to look up a topic in terms of doing games programming themselves, they can just search for a specific topic and maybe find a video where they see me uh, doing stupid stuff like this. So yeah, but yeah, the YouTube series will continue onwards later today. I'm gonna do the jumping mechanic um, afterwards. So right now we have a starting point in terms of implementing. Um, yeah, we actually have done a lot of these things. When we're done with the jumping mechanic, since I think we would be done with the player controller. Um, and yeah, then we need to update the plan in terms of what to do next. Yeah, as I've mentioned, a bit of what I did is not very robust, especially if the project grows. It would end up in a situation where you can't reliably use the parts without risking having a null pointer reference, or rather an invalid pointer. So yeah, we'll have to kind of restructure our program. I suspect the next episodes after applying basic gravity and jumping mechanics to the player controller will be some refactoring. Maybe I do some weapon system programming or build upon the physics system, but yeah, we will see. Anyway, I'm gonna segment off the YouTube video for now. Have a short break, and yeah, do some different stuff. Hopefully you found it helpful, entertaining, inspirational, or something entirely else. Um, Otherwise, maybe you should find something else to watch. Anyway, hopefully I'll be seeing you around.